Welcome back to Human Factors in Engineering class. Today's topic is Human Machines Part 2, Workspace. And I am your class coordinator, Dr. Ezrin Hanis Sukadari. Before we proceed, let's see the learning outcome of this topic. At the end of this topic, students should be able to understand the real needs of workspace, and students also should be able to understand the types of work system. The workspace is the three-dimensional space in which the work is carried out. This required the study of dimension of machine and the dimension of human, which is anthropometry. It also needs knowledge about the activities during work and work rate. There are two types of workspace, which is in this lecture we call it as ergo system. One is simple ergo system. Two is complex ergo system. Simple ergo system means one human and one machine in the work environment. Meanwhile, complex ergo system means one human interact with different machines or several humans used in one system. In any ergo system, there are human and machine components. All ergo systems are communicated with each other by their respective inputs and outputs. The output of particular ergo system may be the input to other connected work system or vice versa. You may refer to the previous slide to recap about the complete ergo system. In this slide, I will show you the details of its component. Human component in ergo system consists of input, sense, central nervous system, which is CNS, and motor sense, MS. The central nervous system is involved in receiving information about the environment around us through sensation and generating responses to that information, motor responses. Sensory input needs to be integrated with other sensations, as well as with memories, emotional state, or learning that we call it as cognition to produce a response. Meanwhile, for response, the central nervous system produces a response on the basis of stimuli perceived by sensory structure. An obvious response would be the movement of muscle, such as withdrawing a hand from a hot stove, but there are broader uses of the term. Machine component of ergo system consists of control, central processing, and display. Control is the human interaction with the machine depends on the presence of suitable controls which are used by the effectors. For example, the nature of man's environment imposes certain constraints on his behavior, such as restricted movement and the field of view. It may also predetermine his behavior, such as stooping, or pick up something, or moving around the corridors of office, or looking for the edge of road while driving. The control process information system, which is central processing, is the basic operation of the machine as central processing unit of the computer and is controlled by the human. And display is the output of the information system, like screen of the computer. The output of particular ergo system may be the input to other connected work system or vice versa. Now, we take a look at the strategies in the design of an ideal human-machine system. The purpose of human factor discipline is to enable the ergo system to function better by improving the interactions between the human component and other components. Most strategies concern with human component, but the other component play a role too. Human error are often attributed to the design of the workspace, which is not to take the characteristic and limitation of the human into account. There are four main strategies to design of an ideal human-machine system. The first strategy is concerned with the stress, which is either physical or mental. Poor design equipment may make subject to assume bad posture that will make abnormal stress on the subject. When this stress exceeds the subject tolerance and limit, the performance and the productivity will decline and safety and health subject will affected too. The second strategy is concerned with the design. Machines and equipments should be designed with the human characteristic in the mind. Good matching between the machine dimension and human characteristic will help the subject to do their job easily, safely, and efficiently. The third strategy is to match the job demand with the people abilities, both physical and behavioral, to ensure a safe and productive lifestyle. So, if the demands of the specific task can be matched with human abilities, it will result with optimal work environment. And if the demand's ability exceed the task demand, we can have safer human-machine system. Okay, the last strategy is the fourth strategy, which is to educate and physically train people to improve their knowledge and awareness of their environment by proper motor learning, which is a set of learning associated with the practice and experiences. That leads to relatively permanent changes in the capabilities or skill performance. After you understand about the designing the human-machine system, now we go to the type or category of work system. There are three categories of work system. 1. Manual work system. 2. Worker machine system. 3. Automated work system. For manual work system, it means worker performing one or more tasks without the aid of powered tool. Worker machine system means human worker operates powered equipment. And automated work system means process performed without the direct participation of a human worker. Okay, now we take a look at the pure manual work system. The pure manual work system involves the physical and mental capabilities of the human worker, and no machine, no tools, or other implement are employed in performing the task. The example of pure manual work system, such as workers loading furniture into a moving van without the use of dollies, and office worker filing documents. Now we look at to the manual work system. Human body accomplishing some physical tasks without an external source of power, with or without hand tools. But when hand tools are used, the power to operate them is derived from the strength of a human worker. A hand tool is a small tool that is operated by the strength and skill of the human user. Other human abilities are required, such as hand-eye coordination and mental effort. Manual tasks are commonly improved by the use of hand tool. A tool is a device or implement for making changes to some object. Example, the work unit, such as cutting, grinding, striking, squeezing, or other process. Example of manual tasks involving the use of hand tools include the following. 1. Machinist filing a part. 2. Assembly working using screwdriver. When worker operates a powered equipment, we refer to the arrangement as a worker machine system. The examples are machinist operating a milling machine, truck driver driving an 18-wheel tractor trailer, worker crew operating a rolling mill that convert hot steel blocks into flat plates. Now, let's see the types of powered equipment. There are three types of power equipment. First, portable power tool. Second, mobile powered equipment. Third, stationary powered machines. Portable power tools are light enough in weight. Mobile powered equipment are generally heavy pieces of equipment. Meanwhile, stationary powered machines stand on the floor or ground and cannot be moved while they are operating. The example of each powered tool or equipment can be seen in the slide. Automation is the technology by which a process or procedure is accomplished without human assistance. It being implemented using a program of instructions combined with a control system that executes the instructions. Power source is required to drive the process and operate the control system. Semi-automated machine, which is periodic worker attentions, perform a portion of the work cycle under some form of program control. Human worker tends the machine for the remainder of the cycle by loading and unloading it. Operator must be present every cycle. The second one is fully automated machine. Operates for extended period of time with no human attention. Okay, that's all for this topic. Stay tuned. Bye. Assalamualaikum warahmatullahi wabarakatuh.